March 1944. In a quiet stretch of Michigan farmland, something enormous was coming to life. A structure so massive, so unbelievable in size it seemed to consume the horizon itself. Inside, the air roared with noise, rivet guns hammering like distant artillery, conveyor belts grinding endlessly ahead, thousands of men and women moving with perfect coordination. They were not fighting with rifles or shells. They were fighting with industry. Every hour, another bomber emerged from the factory floor. Not one each day, one nearly every 60 minutes. Thousands of parts, hundreds of workers, a monument of steel, labor, and relentless determination. Its name was Willow Run, built not for fame but for survival. A system created to outbuild Hitler's Luftwaffe. While Germany tried to dominate the skies, America learned how to manufacture victory itself. This was Willow Run, a factory the world was never meant to fully understand. A machine created for one purpose alone: build aircraft faster than Nazi Germany could destroy them, and it would reshape the war completely. To understand Willow Run, you first have to understand the emergency that demanded its existence. Summer of 1940, the skies above Britain. Luftwaffe bombers crossed the English Channel in formations so immense they appeared on radar like solid walls. Hurricanes and Spitfires climbed to intercept them, weaving through smoke trails and streams of tracer fire. Pilots landed, refueled, and took off again, sometimes flying mission after mission in a single exhausting day. But losses mounted brutally. By autumn, RAF Fighter Command had lost staggering numbers of aircraft. Factories in Coventry, Birmingham, and Southampton operated day and night, yet production still struggled to replace what was being destroyed. Pilots could be trained faster than airplanes could be built, and Britain was running dangerously low on both. Across the Atlantic, the United States watched from a position of official neutrality while political divisions deepened at home. But President Franklin D. Roosevelt understood something many members of Congress refused to accept. If Britain collapsed, America might eventually face the Axis powers alone. In late December 1940, he spoke to the nation by radio. "We must become the great arsenal of democracy," Roosevelt declared, his voice calm yet firm. The wording mattered. Arsenal, not ally, not soldier, but supplier. A nation capable of producing more than any enemy on earth. Soon afterward came the Lend-Lease Act. Signed with sweeping authority, it allowed the United States to send weapons, tanks, ships, and most importantly aircraft to Britain and other allied nations without immediate payment. Aid could flow across the Atlantic, but only if American factories could build enough to sustain it. The challenge was scale. In 1940, the entire United States produced fewer than 6,000 military aircraft. Germany was already operating on a full wartime footing. The Allies desperately needed bombers, heavy long-range aircraft capable of carrying war deep into occupied Europe. Machines that could survive anti-aircraft fire, cross freezing seas, strike enemy industry, and still return home. Aircraft like the Consolidated B-24 Liberator, a rugged long-range bomber created by Consolidated Aircraft in San Diego, but Consolidated's factories had limits. At best, they could only produce a few dozen bombers each month. The military demand was far greater, hundreds than thousands. The United States Army Air Forces ran the calculations repeatedly. To gain air superiority over Europe, replace mounting combat losses, and equip the growing number of bomber groups forming every month, the nation would require an industrial breakthrough unlike anything in history. They needed someone who understood mass production on a scale never before attempted. They needed Ford Motor Company. Henry Ford's company had transformed the automobile industry forever. Assembly lines, interchangeable components, total vertical integration. By 1941, Ford's River Rouge complex in Dearborn, Michigan stood as the largest industrial center on Earth, capable of turning raw iron ore into completed automobiles in less than 2 days. But Ford had never built aircraft before, and Henry Ford himself, now elderly, famously stubborn, and deeply skeptical of another European conflict, showed little enthusiasm for the idea. Even so, the government arrived with more than a request. It came with a contract, a challenge, and the promise that if America was going to survive the coming storm, industry would have to become a weapon all its own. Military planners believed that if Ford Motor Company could adapt automotive mass production methods to bomber construction, the Allies might win the air war before it slipped beyond recovery. Early in 1941, negotiations quietly began. The Army Air Forces needed enormous numbers of Consolidated B-24 Liberator bombers. Ford's production director, Charles Sorensen, traveled to Consolidated Aircraft's San Diego factory to examine the aircraft personally. What he discovered immediately concerned him. Aircraft were still being assembled almost like handcrafted machines, carefully fitted piece by piece, slowly constructed with each bomber slightly different from the next. There was no true assembly line, no strict standardization. Mechanics moved around stationary airframes, installing systems individually in a process that consumed enormous time and labor. Sorensen recognized inefficiency everywhere, but he also recognized opportunity. If the B-24 could be divided into subassemblies, wings, fuselage sections, tail structures, all constructed separately and later combined on a moving production line, manufacturing speed could increase beyond anything previously imagined. Such a plan would demand a factory unlike any the world had ever seen, longer than warships, broader than entire airfields, capable of containing a complete industrial ecosystem beneath a single roof. It would require Willow Run. The location was selected during the opening months of 1941, before the United States had formally entered the war. Willow Run Creek passed through quiet farmland west of Detroit. The terrain was flat, open, and isolated enough for future expansion, while still close to Michigan's massive reserve of industrial workers. Ford purchased thousands of acres of land. Survey crews appeared in the spring, and construction teams followed soon afterward. What emerged from the ground seemed almost impossible to comprehend. The main assembly structure stretched for thousands of feet in length and more than 1,000 feet in width. Walking from one end to the other could take nearly a quarter of an hour. The roof covered an area larger than many military bases, even surpassing the size of the Pentagon, which was still under construction at the same time. Inside the facility, enormous open manufacturing spaces existed without interior support columns for vast distances, creating uninterrupted production floors unlike anything previously attempted. The complex even contained its own power station, rail connections, and airfield. A specially designed runway allowed completed bombers to depart directly from the factory itself. The building became so enormous that workers joked it generated its own climate. On humid days, condensation gathered high above the rafters like artificial clouds. Yet sheer size was not the true obstacle. Complexity was. A single B-24 Liberator contained well over 1 million individual components. It carried 4 engines, multiple heavy machine guns, an immense wingspan, and a fully loaded weight measured in tens of thousands of pounds. Every hydraulic tube, electrical connection, and control cable had to be installed in exact sequence. Hundreds of thousands of rivets needed to be placed with precision because even a small error could doom an aircraft in combat. Traditional manufacturing methods required weeks to complete one bomber. Ford intended to produce one every hour. Charles Sorensen became the driving force behind the project. A Danish immigrant who had risen from pattern maker to senior executive, Sorensen understood both machinery and workforce organization better than almost anyone alive. He had helped create the River Rouge system and refine the moving assembly line. Now he planned to apply those same principles to the most sophisticated machine ever mass-produced. He divided the bomber into major sections: nose assembly, cockpit, bomb bay, wings, and tail. Each section would travel along separate feeder lines before joining the central assembly track. Wings that once required days of exhausting labor to install would now be attached in coordinated operations using specially engineered jigs and lifting systems. Sorensen demanded total interchangeability of parts. Every bolt opening needed to align perfectly. Every panel had to fit without grinding, filing, or individual adjustments. Measurements were controlled down to fractions of an inch. It was automobile manufacturing logic imposed on aviation, and much of the aircraft industry believed it could never succeed. Critics mocked the project and joked that Willow Run would never operate properly. Even engineers from Consolidated Aircraft doubted that workers trained to build automobiles could ever master the demands of bomber production. Many doubted that automobile workers, people with no background in aviation, could ever achieve the precision bomber construction demanded. Critics and newspapers openly questioned whether a company without aircraft experience could fulfill such an enormous promise. Henry Ford himself remained uncertain, elderly, increasingly withdrawn, and still influenced by isolationist beliefs. He avoided the groundbreaking ceremony entirely. His son, Edsel Ford, assumed a far more active role in the effort, though even he faced intense pressure from government officials and military planners. Then came December 1941. Attack on Pearl Harbor changed everything overnight. America was now at war. Neutrality disappeared instantly. Willow Run transformed from a bold industrial experiment into a national emergency project essential to survival. Construction accelerated at extraordinary speed. Federal funding flooded into the site. The Army Air Forces assigned officers to monitor progress directly. Workers arrived from across the Midwest in enormous numbers: farmers, factory laborers, men and women with little industrial experience of any kind. By the opening months of 1942, the massive shell of the facility stood completed. Trains delivered giant overhead cranes, conveyor systems, hydraulic presses, and specialized machinery built specifically for aircraft production. Entire rooms overflowed with technical drawings for the consolidated B-24 Liberator. Training programs began immediately. In September 1942, the first B-24 emerged from the Willow Run assembly line. The achievement arrived months later than originally hoped. Even then, the aircraft still required additional engines and instruments to be installed at a nearby modification center before it could fly into combat service. Early production remained painfully slow, disrupted by shortages, bottlenecks, and constant technical problems. Yet the line was moving, and that alone mattered. Within another year, Willow Run would become the most productive aircraft factory in the world, a place where impossible goals slowly became ordinary routine, a place where American industrial strength began to overwhelm Axis production on a scale Germany could never equal. The once secret factory was no longer hidden. It was operating at full force, preparing to drown the Luftwaffe beneath numbers it could never hope to replace. The workers came from everywhere imaginable: young farm boys who had never stepped inside a factory before, housewives who had never touched industrial tools, skilled machinists from closed automobile plants, teenagers barely out of school, African American workers traveling north from the South in search of wartime jobs and better wages. Women who had spent years cooking meals, cleaning homes, and raising children suddenly found themselves climbing into bomber fuselages carrying blueprints and heavy toolkits. At peak production, Willow Run employed more than 40,000 workers. Operations continued day and night through 3 nonstop shifts. The factory never truly slept. As one shift ended, another immediately replaced it. Past midnight, crews worked beneath harsh fluorescent lighting while the outside world remained dark and silent. Training was fast, demanding, and unforgiving. New employees were often given only days, sometimes mere hours, to learn tasks requiring tremendous accuracy under relentless pressure. A crooked rivet could weaken an aircraft structure. A single wiring mistake could doom an entire bomber crew during combat missions over Europe. Errors carried consequences measured not in money, but in human lives. By 1943, women made up nearly half the workforce. They served as welders, electricians, inspectors, and sheet metal workers. They operated cranes, assembled hydraulic systems, and performed jobs many industrial leaders had insisted women were incapable of handling only a short time earlier. The pace inside Willow Run remained merciless. Supervisors moved along the production lines carrying stopwatches. Daily quotas were displayed everywhere. Targets were broken down by hour, then by minute. One delayed shipment, a broken conveyor, or a missing component could disrupt the entire operation. Injuries happened constantly. Workers suffered crushed hands, welding burns, and falls from scaffolding high above the factory floor. The deafening noise damaged hearing permanently for many employees. There were no modern workplace protections, no required safety pauses, only endless pressure to produce more bombers. Yet morale remained surprisingly strong. Workers understood exactly what they were building. They watched the bombers roll out of the plant and disappear toward war. Letters later arrived from air crews stationed in England, describing missions flown in aircraft built by the hands of Willow Run workers themselves. Letters arrived from bomber crews stationed overseas, thanking the workers at Willow Run for building the aircraft that carried them safely home. The work was exhausting, dangerous, and often poorly paid, yet it carried meaning, and everyone inside the factory understood that. What truly made Willow Run revolutionary was not the bomber itself, but the manufacturing system behind it. Engineers from Ford Motor Company completely rethought every stage of aircraft construction. The consolidated B-24 Liberator, originally designed for slow traditional assembly, had to be redesigned for mass production. Thousands of changes were made to the original consolidated aircraft blueprints so the bomber could move efficiently along an assembly line. The fuselage was divided into major sections: nose, center, and tail, each built separately on feeder lines. Workers installed wiring, oxygen systems, and gun mounts while those sections remained fully accessible. Once finished, the sections moved toward the main production track where giant alignment jigs locked them together with remarkable precision. The wings presented the greatest engineering challenge. Each wing weighed several thousand pounds and contained fuel tanks, landing gear systems, and engine mounts. At Consolidated's original factories, attaching wings required large teams working for days. At Willow Run, Charles Sorensen created a synchronized wing assembly process. The fuselage rolled into position while overhead cranes lowered both wings at the same time. Alignment pins slid into carefully drilled openings. Hydraulic clamps secured everything instantly. Workers rushed into place, driving rivets in carefully coordinated patterns. What once required days could now be completed in minutes. The assembly line itself moved slowly but continuously. The main track advanced only inches each minute, giving employees enough time to complete their assigned tasks while the bomber steadily progressed forward. Sub-assemblies entered the line at exact moments, timed with extraordinary precision. The entire operation resembled an industrial ballet performed with steel, aluminum, and machinery. Tooling systems became equally advanced. Custom jigs, clamps, and fixtures guaranteed repeatability. Interchangeable components arrived already inspected and measured. There was no room for improvisation or guesswork. Every section fit together like pieces of a gigantic and deadly puzzle. By the middle of 1944, the line operated so efficiently that a completed B-24 rolled out approximately every hour. It represented Henry Ford's industrial vision brought to its ultimate conclusion. The moving assembly line transformed into a weapon of war powerful enough to overwhelm an entire enemy nation. The statistics surrounding Willow Run were astonishing. Every day the factory consumed mountains of raw materials, hundreds of thousands of rivets, enormous quantities of aluminum sheeting, rubber for tires and hoses, and endless supplies of bolts and fasteners. Freight trains arrived constantly carrying aluminum from Alcoa smelters, steel from Pittsburgh mills, plexiglass from chemical plants, and engines supplied by Pratt & Whitney and Wright Aeronautical. The factory's power station generated enough electricity to support an entire city. Massive compressed air systems operated rivet guns and hydraulic equipment throughout the complex with incredible force. At peak production, Willow Run completed roughly one Liberator bomber every hour. That translated into dozens of bombers every single day and hundreds every month. During 1944 alone, the factory produced thousands of aircraft. More than the entire German Luftwaffe could manufacture across all its facilities during the same period. By the end of the war, more than 8,000 B-24 Liberators had emerged from Willow Run, representing over half of all Liberators ever built. Those bombers equipped Allied air groups across Europe, the Mediterranean, and the Pacific. They flew missions above places like Berlin, Munich, and Tokyo. Germany could destroy American bombers in combat, but it could never destroy them faster than America replaced them. For every aircraft shot down over occupied Europe, more were already moving down the assembly line back in Michigan. Attrition had become a mathematical problem, and the mathematics now favored the Allies completely. German intelligence became aware of Willow Run long before the war ended. Agents operating inside the United States before Pearl Harbor collected reports describing America's expanding industrial capacity. Commercial aerial photographs revealed the gigantic construction projects spreading across Michigan farmland. Even from the air, the scale appeared almost unbelievable. The scale was impossible to hide and the purpose was obvious, but recognizing Willow Run and destroying it were two completely different matters. Germany possessed no realistic ability to strike the American mainland. The Luftwaffe's long-range aircraft, including the Focke-Wulf FW-200 Condor, barely had enough range to reach Britain and return safely. A bombing raid across the Atlantic remained far beyond German capabilities. U-boats prowled the ocean hunting Allied shipping convoys, not industrial complexes hidden deep inside North America. Willow Run was effectively beyond reach. German planners watched American production numbers with growing fear. Albert Speer later admitted that Allied industrial output became the one factor Germany could never overcome. Germany attempted to respond. Messerschmitt and Focke-Wulf factories operated continuously. Forced laborers from concentration camps were driven into underground production sites. Jet aircraft development accelerated in desperate hopes of gaining a technological advantage. None of it proved enough. By 1944, Germany produced tens of thousands of aircraft annually across every category: fighters, bombers, trainers, reconnaissance planes. Yet Willow Run alone manufactured thousands of heavy bombers each year, and it was only one part of America's vast industrial machine. When combined with production from Douglas, Boeing, Lockheed, Consolidated, and dozens of other plants, the numbers became overwhelming. The Luftwaffe was not simply being defeated in combat. It was being buried beneath industrial output. German pilots understood this reality as clearly as anyone. Veterans who survived into late 1944 described American bomber streams so enormous they darkened the sky itself. Anti-aircraft batteries fired until gun barrels overheated. Fighters attacked until ammunition supplies were exhausted. Still, the bombers kept coming. During interrogations after the war, one captured Luftwaffe officer was asked what Germany could have done differently. His answer was direct: build a factory like Willow Run. But Germany never possessed the resources or safety required to create such a thing. Despite its massive scale, Willow Run still operated beneath heavy secrecy. The government enforced strict wartime censorship. Newspapers could mention that Ford Motor Company was building bombers, but details about production speed, total numbers, and destinations remained restricted. Interior photographs were prohibited. Journalists allowed inside the plant traveled under supervision and often had articles reviewed before publication. Workers received constant reminders about operational security. Posters warned that careless conversations could cost lives. Discussions about production schedules, output totals, or technical systems were discouraged even outside the factory gates. Fear of sabotage remained constant. The Federal Bureau of Investigation monitored employees for possible Axis sympathies. New workers underwent background investigations. Security patrols guarded perimeter fences around the clock. Identification badges were checked at every entrance. Tool inventories were performed during shift changes to ensure nothing disappeared that could reveal American manufacturing techniques. Portions of the enormous roof were even covered with camouflage netting designed to break up the factory's outline from the air. Whether it deceived anyone remained doubtful, but it reflected the atmosphere of anxiety surrounding the war. There were incidents that deepened those fears. Small fires occasionally erupted, some accidental, others investigated as possible sabotage. Mechanical failures received intense scrutiny. In one case, a worker was accused of loosening bolts on a wing assembly. Investigators later determined the issue resulted from quality control mistakes rather than deliberate sabotage. Labor tensions added even more strain. The United Auto Workers represented many employees and demanded higher wages, safer conditions, and fair overtime pay. Official wartime agreements prohibited strikes, yet slowdowns and disputes still disrupted production. Management balanced on a narrow line between maximizing output and preventing total worker exhaustion. Federal mediators intervened repeatedly. Conditions improved slightly, wages increased, and through it all the assembly lines kept moving. The bombers continued rolling out without pause. At the center of the operation stood Charles Sorensen, the architect of Willow Run's production system. He was not known as a gentle man. Sorensen demanded results with relentless intensity. Delays were treated as personal failures. Inefficiency was unacceptable. He walked the factory floor carrying a stopwatch, identifying bottlenecks and publicly confronting supervisors who failed to meet targets. His methods were harsh, but they produced extraordinary results. Sorensen understood aircraft production as a war fought on two fronts, industry and bureaucracy. He battled Army Air Forces officials over design changes, spare part priorities, and delivery schedules. He clashed with engineers from Consolidated Aircraft who resented Ford's modifications to the bomber design. He fought with union representatives, inspectors, and even Ford executives. Yet production increased dramatically under his leadership. By 1944, Willow Run had become the highest-producing bomber factory in the world. Methods once dismissed as impossible for aviation manufacturing became the new industrial standard. Meanwhile, Henry Ford faded further into the background. Age and illness weakened him significantly. His earlier isolationism and anti-Semitic statements turned him into a political liability during wartime. He rarely visited Willow Run and said little when he did. His son, Edsel Ford, handled most government relations until his sudden death in 1943, a loss that deeply shook the company. Even so, the factory continued operating because the true power of Willow Run no longer rested with one individual. It rested in the system Sorensen had created, a gigantic machine made from workers, steel, and industrial discipline, producing the weaponry that would eventually break the Third Reich. By the spring of 1944, that machine reached its full destructive potential. Airfields across eastern England filled with newly arrived Consolidated B-24 Liberator bombers fresh from American factories. Their aluminum surfaces still gleamed beneath cloudy skies as ground crews installed guns, loaded ammunition belts, and painted nose art across the fuselages. Many carried a small marking near the crew entrance identifying their origin, Willow Run. Pilots, navigators, bombardiers, and gunners approached the aircraft cautiously. The B-24 had a reputation for speed, range, and heavy payload capacity, but also for being difficult to fly and vulnerable to combat damage. Still, there were now so many of them that losses no longer threatened to cripple operations. By early 1944, Willow Run achieved production levels few people had once believed possible. The factory rolled bombers off the line day and night with barely any interruption. The assembly line itself seemed alive. Workers moved in perfect rhythm. Components arrived precisely when required. Sub-assemblies merged smoothly onto the main track. Inspectors crawled through fuselages carrying flashlights, examining rivets and welds while production continued around them. Problems still occurred. Paint facilities sometimes fell behind schedule, forcing aircraft to leave the line in bare metal finishes. Engine shortages occasionally left completed bombers sitting idle on runways awaiting power plants. Delays in cockpit instruments meant some aircraft required final equipment installation at modification centers, yet these were logistical complications. Not failures of manufacturing itself. The bombers continued flowing outward in relentless succession, and the Army Air Forces accepted every aircraft as quickly as the factory could build them. In March 1944, large formations of Willow Run built B-24s joined daylight raids against Berlin. Hundreds of heavy bombers crossed into German airspace escorted by North American P-51 Mustang fighters, equipped with external fuel tanks that finally gave them the range to protect bombers all the way to their targets. Black clouds of anti-aircraft fire exploded around the formations, while German fighters tore through the skies, attacking relentlessly. Bombers fell burning toward occupied Europe as crews bilayed out into enemy territory, yet the formations kept moving forward. Bomb bay doors opened and payloads tumbled downward toward rail yards, factories, and government buildings. The city shook beneath the attack. Losses remained severe. Dozens of bombers were destroyed during some missions, losses that earlier in the war would have crippled operations for weeks. By 1944, however, those losses represented only a fraction of ongoing American production. Replacement aircraft arrived faster than Germany could shoot them down. The 8th Air Force, which once struggled to launch a few hundred bombers, now sent more than 1,000 aircraft into combat at once. Willow Run eventually reached peak monthly production during 1944, turning out bombers at a pace that pushed human endurance to its limits. Workers endured endless overtime. Shifts overlapped continuously. The line never truly stopped moving. Completed bombers immediately departed for modification centers where radios, gun turrets, bomb sites, and survival equipment were installed before aircraft moved onward to training bases or overseas deployment. By summer, Willow Run bombers operated across every major theater of war. Over France, they attacked V-1 launch sites and fuel depots. Over Germany, they bombed synthetic oil facilities and transportation hubs. In Italy, they supported Allied offensives against rail networks and troop concentrations. Across the Pacific, their long range and payload capacity made them ideal for strikes against Japanese-controlled islands. The cumulative impact became devastating. German industry, already weakened by territorial losses and the enormous demands of the Eastern Front, slowly began collapsing under the bombing campaign. Factories moved underground. Production quality declined. Even the organizational talents of Albert Speer could not match the combined industrial power of American factories operating safely far from enemy attack. Germany fought the war it had started. America manufactured the war it intended to win. By mid-1944, the balance in the skies above Europe had shifted permanently. Then came Normandy landings. Before landing craft reached Omaha Beach and before paratroopers descended into Normandy, waves of Allied bombers filled the night sky. B-24s, B-17s, medium bombers and fighters attacked coastal defenses, artillery positions, bridges, and communications centers. Their mission was simple: isolate the battlefield, delay German reinforcements, and protect the invasion fleet from counterattack. Willow Run-built Liberators flew countless sorties during the operation. Some crews were seasoned veterans while others entered combat for the first time. Many bombers flew through heavy cloud cover and released payloads using radar navigation without ever seeing their targets directly. It hardly mattered. The sheer volume of explosives shattered roads, destroyed bunkers, and silenced communications across northern France. Reinforcements that should have reached the beaches quickly were delayed for days. The Luftwaffe, once feared across Europe, barely appeared during D-Day. Allied aircraft launched tens of thousands of sorties while German air forces managed only a tiny fraction of that number. The imbalance was no longer about courage or pilot skill. German aviators remained experienced and determined, but no amount of bravery could overcome the industrial flood pouring out of factories like Willow Run.